Hello everyone. In this lesson, we will talk about derivatives of the function e and the natural logarithm. Before I get into differentiating y equal to e raised to this exponent, the fifth root of x squared, I would like to remind everyone of the essential formulae that I provide to everyone in previous video. We will concentrate on formula number 12 and number 13 in this lesson. Derivative of a natural logarithm of a function is equal to 1 divided by that argument as a function u, and again we still have to multiply by derivative of u as a function of x. And if you want to find derivative of e raised to certain power, and this power is a function in terms of x, then the solution will be the exact same thing again, e to the exponent u. Again, we multiply by derivative of u as a function of x. So we always have to multiply by derivative of the argument in this case. As you can see, in most of the formula that we have been working with, the final step is multiply by derivative of your argument, derivative of u as a function of x or with respect to x. Again, all the basic principles for differentiation still applies. So we still have to apply the power rule or the chain rule, and if there's product rule, we have to follow these formulas right here. And if there's, in case of we have two functions divide into each other, then we have to apply the quotient rule. Alright, so let's get back to our lesson. This example 1. So in this case, I would like you to think of this function like this. So you're going to write y equal to e to the exponent u, right? So you need to have e to the exponent u in order to apply the formulas, the derivative of e to the exponent u as a function of x will be equal to e to the exponent u multiplied by derivative of u as a function of x. So this is the formulas that you need to apply. So in this case, what you need to do is you have to modify, or you have to write your function as e to the exponent u. So then right away you know that you are going to differentiate y. It means dy over dx will be equal to e to the exponent u, and then you multiply that by du over dx. Okay, but we don't finish it here. We have to identify our u, and then we will have to find the derivative of that. So in this case, you apply the exact formulas that given to you in this case. So since I let u equal to the fifth root of x squared, so you can rewrite it as x raised to the exponent 2 over 5. Okay, then du over dx will be equal to 2 over 5 times x raised to the exponent of 2 over 5 subtract 1. So when 2 over 5 you subtract 1, it means 2 over 5 subtract 5 over 5. So in this case, your answer should be negative 3 over 5. So x to the exponent negative 3 over 5. Alright, so all you have to do now, just substitute this into these formulas. So dy over dx will be equal to, so let me put this in this area so we can separate our work. Dy over dx is e to the exponent u, so we write e to the exponent fifth root of x squared, and I multiply that with 2 over 5 x raised to the exponent negative 3 over 5. So in the end, if we have to write this as positive exponent, So what you do is you write 2e to the exponent 5th root of x squared, everything divided by 5 times x to the exponent 3 over 5. Alright, so this is the final answer. Okay, so basically what we have to work with is we are working with these formulas right here. Identify the exponent of e as your function u so that you can match with these formulas, and then you differentiate u as a function of x and then substitute it into the formulas. Alright, so for the next question. Okay, so next question is a similar approach. It's just that I have the one function adding to the other, and they both as a function of e raised to the exponent, and e raised to the exponent. So for differentiation of sum or difference of more than one or two functions, so all you have to do is just differentiate each one of these individually, and then you can just add them together. Okay, so in this case, I will write dy over dx equal to, so e to the exponent q root of x, so the exact same thing again, right? Q root of x, and then I multiply this by derivative of q root of x. So derivative of q root of x, we can try to do it on the side here. So we have x to the exponent 1/3. Okay, so then du over dx will be equal to 1/3 x to the 1/3 subtract 1, so the answer should be negative 2/3. Okay, so in this case I multiplied it by 1/3 of x raised to the exponent negative 2/3. Okay, now I add that with e to the exponent of x squared, so exact same thing repeating, multiplied by derivative of x squared, in this case which is 2x. Okay, so in the end the final answer should be e raised to exponent q root of x, the whole thing divided by 3x to the positive 2/3, adding it with 2x times e to the exponent of x squared. Alright, it's quite simple. Okay, so let's move on to the next question. Okay, this question I have here is a product rule, as I indicated to everyone, because you have a function of 5 times x squared, and then you multiply that with e raised to exponent 2x. So in this case, the product rule said this: you are going to write u times dv over dx plus v times du over dx. Like I mentioned in previous video, it's safer to identify the very first function as u, second function as v. So I always go with that, but in some cases it doesn't matter because you have a plus right here. But I will always pick the first function as my u and the second function as my v. Okay, so then if I let u equal to 5x squared, then du over dx in this case should be equal to 10x, right? Alright. And if I let v equal to e to the exponent 2x, so dv over dx will be equal to the exact same thing again, right? Derivative of e to the exponent is the exact same thing again, but multiplied by derivative of the exponent of e. So derivative of the exponent of e, in this case 2x, is equal to 2. Okay, so now all you have to do is substitute all this into your formulas. So u in this case will be 5x squared. So now I will write dy over dx. So I want to remind everyone to be mindful of your notation. Okay, so once you differentiate, you make sure that you write dy over dx on your next line. So then it will be equal to u, which is 5x squared, and then I multiply this with the dv over dx. Okay, so u times dv over dx, which is e raised to exponent 2x times 2. And then I add that with v, which is e raised to exponent 2x. And I multiply that with du over dx, which is 10x. Okay, so let's see what we have in this case. Okay, so in this case, I should have 10x squared times e to the 2x plus 10x times e to the 2x. So we have to simplify our answer. Simplify our answer means that we must find the common factor. So the common factor in this case, you see that this is a 10x. There's a 10x there. And the e raised to the 2x and e to the raised to the 2x. So I would take out the common factor of 10x times e to the exponent 2x. Inside the bracket, I have left with this x as the first term. The second one should be 1. Alright, okay. So a quick reminder here. If you take common factor of certain terms, that means that you have to divide it into each of these terms. So in this case, it's actually quite simple. So I think I will not go over the behind step or the factoring. So I hope everyone realized that 10x times e to the exponent 2x is a common factor. So you have 1x left over for this term. And this one, you bring everything out, so it turns out to be a1. Alright, so let's move on to the next question. The next question I have is 5 times natural logarithm of the function 2 times x to the exponent 3 minus 4. Okay, so let's review. When we find the derivative of natural logarithm, then what is the formulas for that? Alright, so the formulas for this should be derivative of ln of u as a function of x, okay, will be equal to 1 over u times du over dx. Alright, so this is the formulas we write down to remind ourselves. So in this case, you can see that u is equal to 2x to the exponent 3 minus 4. So then du over dx in this case would be just 6x squared minus 0. So if I write dy over dx, okay, in this case, the 5, you will have to leave it. So 5 multiplied by 1 over u, so 1 over 2 times x to the exponent 3 minus 4, multiplied by 6x squared. Then all we have to do here is just simplify our answer. So in this case, what we have is we should have 30x squared, the whole thing divided by 2x to the exponent 3 minus 4. However, I can simplify this further. So I will factor out the 2. So I should have x cubed minus 2 left inside the brackets. And you can see that and that cancel will give you a 15. So the final answer is 15x squared, everything divided by x to the exponent 3 minus 2. Alright. Okay, so this is just simple enough. And one thing that I emphasize to everyone in this case is the 5 as a coefficient multiplied by this. You still have to keep it as multiplied by. Alright, okay. So let's move on to the next one. Okay, so there are 2 questions that I have in this particular page. I have question 5 and question number 6. The purpose is to ask everyone to identify the difference between the two. So here is my question number 5. Natural logarithm of q root of x squared minus 2 as the argument. Okay, so let's move on to number 6 to see what I have. For number 6, I have ln raised to the exponent 3 of 2x plus 1. So in this case, I'm asking everyone to remember the power rules, because you have a power applies to your natural logarithm in this case. Alright, okay, so let's work with this question. And then I will emphasize to everyone the difference between the two. Okay, so first of all, here's what we are going to do. You are going to identify u, right? So immediately you will let u equal to the cube root of x squared minus 2. And then you differentiate the u. However, you can apply some property of logarithm in this case, and then you can simplify the process of differentiation. Okay, so let's review the property of logarithm. So if I have okay, so note property of natural logarithm. So if I have natural logarithm of an argument n raised to exponent p, so I can bring the p to the front and multiply by the natural logarithm of n. So this is the formulas that I'm asking everyone to pay attention to. Alright, so then for this, I haven't differentiated yet, so I still write the y equal to natural logarithm of x squared minus 2. And this is actually raised to exponent 1/3, right? Okay, so cube root of this is raised to exponent 1/3. So if I apply this property of logarithm, I can rewrite it as y equal to 1/3 natural logarithm of x squared minus 2. So then if I differentiate, it will be very simple. So now I will write dy over dx. Then I will have it as 1/3 multiplied by 1 over u. So let's review. Derivative of natural logarithm of u as a function of x could be equal to 1 over u times du over dx. Okay, so this is our formulas. So 1/3 times 1 over u, so times 1 over x squared minus 2. And then I multiply by derivative of u. In this case, it's just simple as 2x. So then I write 2x. Okay, so then all I have to do in this case is just simplify my answer and write it as 2x divided by 3 times x squared minus 2. Okay, so it's very fast if I in fact just apply the property of logarithm and I apply correctly as well. So don't forget, in some cases we have to be very careful to see whether or not we can apply some property of logarithm. So because I raise the argument of natural logarithm to an exponent, I can use this property by take this exponent of my argument and multiply it as the coefficient of my natural logarithm. Then from there, I differentiate. So in the next page, I would like to go over the step where I don't use the natural logarithm properties of this formulas right here. So if I don't use this formulas right here, so I have to work with a few more steps. Okay, so let's do that. So what if I do not apply property of logarithm? Okay, so in this case, what you have is y equal to natural logarithm of cube root of x squared minus 2. Okay, so then you let u equal to x squared minus 2 and raise the exponent 1/3. So you have to apply everything here. So du over dx will be the chain rule. 1/3 of x squared minus 2 raised to exponent negative 2/3 because you take 1/3 subtract 1. Okay, and multiply by 2x, which is the derivative of what inside the brackets. So then here's your du over dx. So I would leave it like that for now. Now, so dy over dx will be 1 over u. So there will be 1 over x squared minus 2 raised to the exponent 1/3, because this is your 1 over u. Okay. And then you multiply by du over dx. So you multiply by 1/3 times x squared minus 2 to the exponent negative 2/3 and times 2x. Okay, so in this case, this whole thing here is your du over dx. So what you do next is you have to simplify your answer. Okay, simplify your answer. You see that the 2x here, I leave that, and the 3, I leave that, but here is what you need to simplify. Okay, negative 2/3, and down here you have x squared minus 2 to the 1/3. Okay, you realize that this is the two base that is the same base. We have the exponent. You divide two powers with the same base, so you subtract the two exponents. So in this case, if I bring this one up, I will have negative 2/3 subtract 1/3. So negative 2/3 subtract 1/3, I should have negative 3 over 3, so I should have negative 1. Okay, so in this case, simplifying this question, I should have 2x divided by 3 times x squared minus 2 raised to the exponent negative 1. Then I bring it down to the bottom, make it to a positive 1. Alright, okay, so I can make a note here that x squared minus 2 to the negative 2/3 subtract. So in this case, I should have a negative 2/3 subtract 1/3. So I should have it as x squared minus 1 to the negative 1. Right? Okay. So, and I bring it down to the bottom to make it a positive exponent. So in the end, you see the final answer is still the same. However, it's more tedious and more steps. So here, we just apply property of logarithm. We get this answer. And in this case, we don't apply the property of logarithm. We have to differentiate, and the simplification process a little bit more complicated, but at the end we still have to get the correct answer. Alright, so now let's move on to question number 6. Okay, so now you see this is the power rule. The power rule, because you have the exponent, goes with the natural logarithm. So in this case, dy, excuse me. Okay, so in this case what I have is I will have dy over dx. Okay, so dy over dx, the first thing is to apply the power rule. So take 3, multiply out here, so 3 ln square of 2x plus 1. Okay, so I'm going to remind everyone this apply the power rule. Then the next step is to multiply by derivative of natural logarithm. So in this case, it will be 1 over 2x plus 1. So this is your 1 over u. And then this will be your du over dx. So in this case, it will be just 2. Alright, okay. So that's 3 steps, and make sure that we remember those 3 steps. So in the end, when we simplify, we are having it as 6 ln square of 2x plus 1, the whole thing divided by 2x plus 1 as the final answer. So make a note here that ln to the exponent 3, okay, we have to apply the power rule. Okay, so ln of whatever in here, that means we have to apply the power rule. Okay, so let's see what I have next. Okay, I have 2 more questions. I think I do have enough time to complete the 2 questions. So the next question I have is natural logarithm, but my argument is a sign. Okay, so it looks complicated, but in fact it's not that complicated if we just follow the process. Okay, so you just have natural logarithm of a function. It means you still apply 1 over u and then time du over dx. So dy over dx is equal to 1 over sine of 2 times e to the 5x. So this is my 1 over u. Okay, so the next step is to multiply by derivative of sine. Derivative of sine will be cos, so it is cos 2 times e to the exponent 5x. Okay, so the next step is I have to find the derivative of 2e to the exponent 5x, right? So derivative of 2e to the exponent 5x is the exact same thing again. And then I multiply by derivative of the exponent of e. In this case, it should be 5. Okay, so let's make a note for everyone here. So this is a derivative of sine. So this is derivative of e. And then this is the derivative of exponent of e. Okay, so just a few steps. So dy over dx, the final answer should be 10 e to the 5x multiplied by cos of 2e to the 5x, the whole thing divided by sine 2e to the 5x. So if you note that cos over sine is cotangent. Okay, so in the end I can write the answer as 10 times e to the exponent 5x times cotangent of 2 times e to the exponent 5x as the final answer. Okay, so if you have to apply trig identity, then we should. Okay, so let me show you on this formula sheet. You can see that I give you some trig identities here. So the trig identity that we are going to use is actually this one. Tangent equal to sine over cos. Okay, but if cos over sine will be equal to cotangent because cotangent is 1 divided by tangent. Alright. Okay. So I think I have one more questions and I only have 3 minutes left, so I believe that I still have enough time. Okay, so I have derivative of natural logarithm of secant of x plus tangent of x. So in this case, I immediately apply the derivative of ln, which is 1 over secant of x plus tangent of x. So in this case, 1 over u. Okay, so this one, I will write it to everyone that this is 1 over u. Now I will multiply by derivative of secant of x plus tangent of x. So derivative of secant of x is just secant of x again and multiply by tangent of x. What is derivative of tangent of x? Is secant square of x. Okay, so don't forget I get all of these from the formula sheet that I provide to everyone. So here's derivative of secant is the secant of u times tangent of u, and derivative of tangent is secant square of u times du over dx, and in this case times du over dx means that just the x, so derivative of x is just 1. So in this case you just have secant of x times tan of x plus secant square of x. So I think for this question the simplification is what we need to concentrate on. Okay, so what I have is, for this part, I should write it as du over dx here. Okay, so I can factor out the secant of x. So factor out secant of x, I have tan of x left plus secant of x left inside the brackets. So in this case, you see that that and that cancel out. So in the end, dy over dx, which is equal to secant of x as the